Components of velocity and acceleration. Components of velocity. Components of velocity and acceleration. Motion of a particle. Motion of a particle in straight line. Motion of a particle in straight line. This is the particle motion, and this is the straight line. Motion of a particle in straight line is known as linear motion. Linear motion. It is possible to treat motion in a curved path. By considering the tangential velocity or by resolving the motion into two linear components. For example, the earth rotates around the sun. This is the sun, and this is the earth. Earth rotates around the sun in its nearly circular orbit. Earth is rotated around the sun in its circular orbit. Its speed is approximately constant. The speed of Earth is approximately constant, but its direction is constantly changing. At any particular instant, direction is changing because the Earth is moving around the sun in a circular path. So the direction is changed and the speed is approximately constant. Its velocity has a definite direction. It traces a curved path along the arc EA. But the instantaneous value of its velocity is its velocity is along the straight line EV, tangent to the path. Thus, at any particular instant, its instantaneous velocity is along tangent to the path, and we refer it as a tangential velocity. Tangential velocity. Displacement. Consider a particle moving along a curve in the plane. The position vector, the position y a point P. This is the y-axis, and this is the x-axis. And this is the unit vector r, so distance, and vector r equal to r dot unit vector r, and this is the point P, and the unit vector of theta. This is the unit vector of theta. Point P in a coordinate system can be specified by the single vector. The distance of the particles related to the origin O. Of the coordinate system. This vector is called the position vector. Of a point, and denoted by OP, vector OP equal to vector R. It gives the magnitude as well as the direction of the displacement. It gives the magnitude. It gives the magnitude. It gives the magnitude as well as the direction of the displacement. If unit vector R is unit vector along OP. R is unit vector along OP. OP is that along the direction of R. Is that along the direction of vector R. Then vector R equal to R unit vector R. R unit vector R. When a particle is moving along a curve in a plane, when a particle moving along a curve in a plane, it has velocity and acceleration. It has velocity and acceleration. First we calculate the velocity. First we calculate the velocity. The velocity is the derivative of displaced vector R with respect to time t. The velocity is the derivative. The velocity is the velocity is the derivative of displacement vector R with respect to time t. With respect to time t. So velocity vector V equal to d by dt vector R equal to d by dt R unit vector R equal to derivative of R into unit vector R plus R into derivative of unit vector R. So the value is dr by dt unit vector R plus R into d unit vector R by d theta into d theta by dt. We are multiply the d theta and divide d theta, because d theta and d theta cancel out together and the value is dr d unit vector R upon dt. So but d unit vector R upon d theta equal to unit vector theta. So velocity V equal to velocity V equal to d vector R upon dt equal to derivative of R unit vector R plus R derivative of theta unit vector theta. So where derivative of R equal to dr by dt and theta derivative of theta equal to d theta by dt. Then the value of velocity vector V equal to vector VR plus vector V theta. Components of velocity. Velocity. The quantity VR vector Vr equal to derivative of vector r unit vector r is known as the radial velocity. Vr equal to derivative of r into unit vector r is known as radial velocity. Is known as radial velocity. Radial velocity. And due to the change in magnitude of r and theta remaining constant and v theta, vector v theta equal to r derivative of theta dot unit vector theta is known as transverse velocity. Transverse velocity. And due to the change in theta r remaining constant, the magnitude of radial velocity magnitude of radial velocity v r mod of vector v equal to derivative of r and magnitude of transverse velocity. Magnitude of transverse velocity. Magnitude of transverse velocity mod of vector v theta equal to r into derivative of theta. If theta equal to constant equal to omega, the angular velocity v theta equal to r into omega. The magnitude of velocity v. Wait just a minute. The magnitude of velocity vector v is vector mod of vector v equal to v under root of vr vector vr square plus mod of vector v theta square equal to derivative of r square plus r square into derivative of theta square whole power 1/2. This is the components of velocity. And we will know about the acceleration. Acceleration. Next is acceleration. Acceleration is the derivative of vector v with respect to time t. Acceleration, you wait just a minute, please. We will know about the acceleration. Acceleration is the derivative of velocity v with respect to time t. Acceleration equal to vector a equal to acceleration is denoted by small letter vector a. Acceleration a equal to dv by dt equal to d upon dt derivative of r unit vector r plus r derivative of theta into unit vector theta. Then we derivate this value is r derivative of double derivative of r unit vector r plus derivative of r, derivative of r unit vector dr by dt plus derivative of r, derivative of theta unit vector theta plus r double derivative of theta unit vector theta plus r derivative of theta d unit vector theta by dt. Where is double derivative of r unit vector r plus derivative of r bracket in bracket d unit vector r upon d theta into d theta by dt plus derivative of r, derivative of theta and unit vector theta plus r double derivative of theta unit vector theta plus r derivative of theta d upon d theta unit vector theta into d theta by dt. But d and d upon d theta unit vector r equal to unit vector theta and d unit vector theta upon d theta equal to minus r unit vector. Then the acceleration a equal to double derivative of r unit vector r plus derivative of r derivative of theta into unit vector theta plus r derivative of r derivative of theta into unit vector theta plus r double derivative of theta unit vector theta minus r derivative of theta square into unit vector r. So in a bracket double derivative of r minus r derivative of theta square unit vector r plus r theta double derivative plus 2 r theta r derivative of r into derivative of theta bracket is closed and unit vector theta. Then acceleration a equal to ar vector ar plus vector a theta equal to ar unit vector r plus a theta unit vector theta. Components of acceleration. The quantity ar is known as radial acceleration. The quantity ar is known as radial acceleration. This is the radial acceleration and this is it is directed away from the center. The quantity r derivative of theta square gives the centripetal acceleration. R into theta r square gives the centripetal acceleration. Centripetal acceleration. Centripetal acceleration. Where is if theta derivative of theta constant a equal to omega, then r derivative of theta square equal to r omega square. Due to change in theta, it has negative sign as it is directed towards the center. The quantity vector a theta is as a transverse acceleration. Vector a theta is a transverse acceleration. A theta is this is the transverse acceleration. This is the transverse acceleration. Vector a theta mod of vector a theta equal to r double derivative of theta plus 2 derivative of r into derivative of theta, and its direction is along theta. Its direction is along theta. This is also consists of two parts. First number is the quantity r double derivative of theta gives the angular acceleration due to change in this is the angular acceleration due to change in unit vector of theta. The quantity 2 are unit vector the quantity derivative of r and derivative of theta arises due to interaction of linear and angular velocity due to changes in r and theta respectively. This is similar to Coriolis acceleration, and ar and a theta are perpendicular to each other. The magnitude of mod of vector a is given by mod of vector a is equal to, in a bracket, ar mod of vector ar square plus mod of vector a theta square, whole value is 1 by 2. It's okay, clear?